Hello, everybody. Welcome to today's device management interface call. Thanks for joining. As usual, the call is public and recorded and will be shared live on YouTube. So please be mindful of the comments you make and the information you share. They will be live. First up, there's still a couple of JIRAs that we discussed last time, which are related to power of the transceiver and state of the transceivers. There was an action item to understand if these could be retrieved by ONLP and Adtran platform APIs, and one to check if this is exposed via our API. So I'm asking Holger or the guys at this is Chandra, maybe if you have more knowledge about this.
I'm sorry, I forgot about checking. We'll do tomorrow.
Okay.
I promise.
Now let me maybe tag you so you should receive an email.
Yep, that's better.
Sure, on the ONLP, I'll update Andrea.
I'll tag you as well. So get an email and we know it's this. Amit, do you recall if it's actually exposed via our API, this value, or if something we need to add? I haven't looked, I have to say, my bad.
I think it is exposed, the RX and PX powers of the transceiver.
Okay, perfect. Then that's good for us. Okay, so last time there was a discussion on the events during rebooting and things like that. But before we go there, let me maybe finish up some of the things that we have down here below, and so we can take them out of the agenda for next times. So to be honest, I don't recall what this uptime was. There was an action item for you, Chandra. It was just added here. This is the last booted event. Is this good enough? Can we close this task?
Yes, for the uptime, we should be good with that API. And for reboot reason APIs, I have come up with the list of reason codes. Maybe in this meeting, can we go through them and get the inputs, or
sure, why not? Do you have them already?
Yes, I have them listed. Maybe I just want to run through them and see if it makes sense or something need to be added.
Yeah, sure. Send feel free.
Okay, sure. With your permission, I'll just share my screen.
Mm-hmm.
Hope you are able to see the screen I have shared.
Mm-hmm.
So this is the reboot reason.
No, hold on, Chandra. I'm still the one sharing the screen. I cannot see your screen. Let me stop sharing. Please go ahead.
Hope you're able to see the screen now.
Yes, now we can.
Okay. So this is about sending the exact reason why there was a reboot of the device. These are some of the codes that we gathered from our understanding about the OLT system. One thing is maybe from the OLT command line interface, somebody can trigger a reboot command. So this we say CLI triggered reboot. And the device is going for a reboot because of that. And next one is the administrative reboot. As we have exposed the reboot, somebody can trigger the administrative reboot from the northbound systems, like name. That is when this will be sent. And there can be software watchdog that will monitor for all the critical applications on the device. For example, the BAL application, the OpenOLT agent, and different other critical application. It will be doing a periodic monitoring, and moment one of these applications are crashed or not running anymore, so it might do a software restart. This is just a soft restart, not a complete device reboot, but application restart. Again, it varies from OLT to OLT. Somebody may do complete device reboot to restore the and initialize the system again, or it can be just a soft application restart. Apart from that, as part of the software upgrade procedure, whenever we activate software or rollback to standby, there will be definitely a reboot triggered. That is the software upgrade triggered reboot. Apart from this, there can be like hardware supporting the watchdog that will trigger a reboot whenever there is a kernel or system hung condition. Maybe hardware can also trigger the device reboot. Then, like the Broadcom Aspen, Maple, or Qumran, these CPLD firmware also can trigger the reboot whenever the temperature overshoots and goes beyond the configured or default thresholds, temperature threshold configured. And next one is if somebody presses the physical power button or reset button, that will also trigger a reboot. So these are some of the things what we have, and also the additional scenario can be like even the platform ONLP also can monitor for the temperature overshoot, and it can trigger the reboot. And we can make use of the Linux C group watchdog, which is a Linux software watchdog, which can trigger a reboot in case of out of memory related system shutdown and come back. And if somebody abruptly removes the power cable, which is a single source of power, if device can detect that, and next time when it comes back, it can say, okay, I was rebooted by somebody pulling out the power cable. So these are different additional scenarios we have. Maybe I would request your inputs here from this forum.
Yeah, so Chandra, my first question on this is, where do you intend to use this enum? Because there's no placeholder for this enum right now.
Yes, Amit.
Wasn't the discussion to add it to the reboot event? Yeah, that one.
Yeah, I just put here the event structure. As Amit mentioned, currently there is a string that can carry additional info. There is no additional enumeration placeholder as of now.
Yeah, so that's what I was coming to. That why do we need it to be an enum? Why can't it be a string?
That was the discussion we had last time, and given that these are a set of elements that could be used by the NEM, we wanted to be more descriptive, so that NEM, if it wants to act on a specific set of things that happened within the device because of that caused the reboot, it could do so, and it doesn't become a vendor-dependent string. That's the reason. I mean.
Okay, because see, we can introduce a enum there, but this enum is specific only for reboot, right? So we can't put it in event.
We can have a child event called reboot event. That's the same type of event that you.
How? Because the events are getting dropped onto the Kafka bus, right? So when you pick out an event from the Kafka bus, then first you need to check whether it deserializes as an event or a reboot event, which is a lot of additional overhead.
I mean, what's the issue of having it as in the event and not setting it if it's not a reboot event?
No issue really. It's just that we use a field which is not really generic enough. which is only for a event, right? One type of
Mhm.
event, putting it in a standard this thing. So yeah, it's just that. But I don't know. I think that having it as a uh, what do you say, a string itself is good enough, because if I look into some of these reasons, I don't know if every OLT vendor is going to have the same reasons. Like,
Yeah,
for
that
example, a software watchdog triggered reboot, right? This might not be generic across all OLT vendors. So the name cannot put a check on this particular value because it doesn't
so
know if
yeah.
it
So
will
to
get it
that,
from a particular OLT vendor or not.
But if we relied on strings and each vendor had a different string, then would have nothing to check on,
yeah. So to that,
right? Because
I agree. And same what my same point is what David was saying. If these might be a little bit specific to the OpenOLT, if we generalize them, it's up to us to do so. I would think that it would be very valuable to have them, but again, open for debate.
yes, I
Yeah,
think we generalize them so they're not specific to any given vendor or implementation. But we have to have them formalized, else it becomes a wild west, and no North company can really manage that. We
Yeah,
get into
so
multi-vendor scenarios.
yeah, I think I agree to that point. So if the name is going to write any logic based on the specific reasons, then yeah, absolutely, yeah, enum is definitely much better than, or is the way to go. I don't think we should use strings. So in that case, I think that's fine. I was thinking more about maybe the name doesn't really care about the reason of the reboot. It is more interested in the reboot, and maybe this specific reason could be more of a diagnostic as to let the operator know what is happening, but no logic based on that. But if that is not the case, then yes, we can go with an enum, yeah, and we could introduce a one-off kind of a field inside the message and have it only for specific events. Yeah.
okay. I would say we do that.
Okay.
But we need to generalize those things. So I believe that, for example, the CLI administrative power reset button, possibly power cable pullout could be good. We could have a generic system triggered reboot, something like that, that encompasses the watchdog, the CPLD, and the out of memory and Linux kernel panic. That could be like a generic one that encompasses all of those, because as we pointed out, not all vendors might have this specific set of things. So might not even have the CPLD module or the something like that. Might not have the watchdog, so that has to go away. The software upgrade triggered reboot. I think it's a good one to have.
Yeah, sure. Maybe I'll share this. Maybe we can further discuss more the review. You can add in, suggest more, or refine this.
Mhm. Yeah, okay, maybe send them over via email or put them in the notes. Do a first pass at generalizing them. You already know what our thoughts are, so you can go ahead and do a first pass. And after you have done the first pass, we can then actually do some comments on those on the email thread or something. Okay.
Sure, Andrea. Thanks, everyone. Thank you.
Okay. Let me take back screen sharing. Okay. So there was a question on the component parallel child. It was shared by Atran and the BBSIM. Is there any more action item that we need to take over here?
I think this should be good entry in my view. This is good.
Okay, so you got all the information you needed?
Yes, yes.
Okay, awesome, perfect. So we talked about a reboot API in the device manager, but we didn't really reach a conclusion on if we want this in or not.
Oh, yeah.
My take is it didn't hurt. It doesn't hurt to have it, but
Yes, and we already introduced this. It's code.
Okay, perfect. Sorry, my bad then.
This also we can close.
Okay,
Reboot.
great. This one, does anybody remember what this is? Because I don't.
Yeah, this is one of the proposal I think someone had with respect to maintaining a hash, and that can be used for it by the system, whether the session is the same or device has gone through a reboot and now the hash is altogether different, and you may want to do some reconciliation or audit based on that. But now we have a separate reboot API. We can discuss if this hash thing is required for the device implementation.
Is this like the configuration hash, so you know if things have changed since you last talked to the device, and do a quick check on a value versus have to do a complete diff of a config type of thing?
That would be my assumption, yes.
So generate the hash based on the latest configuration, and if there is a configuration update, you regenerate the hash. Is that what you said?
And the hash can be retrieved via some API. And this helps you, making a diff in the case you want to analyze the configuration for any reason.
Okay. So then there should be an API update to retrieve this by the normal systems from the device.
From the device or from the device manager, yes.
I thought we had talked about one time that the hash was going to be sent back with a common message, like the hello message, so that you didn't necessarily have to get a second call. I mean, might be worth it to have it as a separate call as well, but I vaguely remember something like that.
So, Andrea, I have a question here. It's a very generic question. So some of these features that we're talking about, right? So do we have requirements for them? So at least say, we have some requirements that are coming from Deutsche Telekom, and who are the only ones who are using it right now, this interface. So if somebody else is also using it, it would be good to know the requirements, because we can keep building on a lot of features, but if there are no requirements and no one is using it, they just keep lying there, right? And we need to keep supporting them. So which takes up resources. Yep. So if we have some requirements, it would be good to know.
This is not a requirement from anybody, as far as I know.
Right, because I think,
yes.
see, one of
this
the things
was a technical requirement based on a technical need. I thought it were originated. I mean, there's going to be custom requirements, and then there's going to be requirements based on implementation. Don't remember where the source of this was, but there was an issue with having to get the whole config or tell when a config was changed. And so this was introduced to that. So I guess that customers are not always the only ones that, have requirements, but sometimes other reasons.
Yes, David. So that's exactly what I'm trying to come to, right? So if there are multiple entities who are modifying the configuration, this is absolutely needed, right? Because you don't know when the configuration changes. But if the deployments or the use cases that we are talking about today don't address that, then maybe we can leave it out for now. And yes, address it when the need comes.
again, I don't remember the source of this one. It had something to do with someone needed to be able to tell if the configuration was changed after a reboot. And that's how this one got introduced. If no one remembers the source, I kind of agree with you. You can't figure out why it's still there, then I'm okay with leaving it out until the person who needed it speaks up.
Okay. I think we can shelf it for now then. Maybe it's part of the discussion over here. The other one I have here is a stop-start managing device in the case of a single device. I don't recall what this is, and I don't think it's an issue, meaning that there's no. Sure, you start managing the device, even though when you get the connection to it, but shouldn't be any problem in this. It's just maybe redundant. You could say so, but that shouldn't be an issue. So my take of this one is not needed. Not needed. Okay. Same for this one. Just doing some cleanup because otherwise this is. Okay. So there was a discussion on what NEM needs to do on a specific set of image processing during the image update. And there was a question what you guys have an AgTrend in terms of steps. And you said that the intermediate steps can happen in any order. And so we just don't have one. You should expect that you start updating and then either the update is successful or it's not. And that was it.
Yes, mainly we understood that this upgrade is related to the download procedure, not really the activation procedure. This is just an upgrade of the image on the standby partition. Yeah, I got the clarification from the last meeting, but do we really want to document in the DMI? We can take a call. What exactly this upgrade means?
I think if it was not clear, I think we should. So, given that you are the one that started the discussion, do you mind sending up a small update to the documentation for this?
Sure.
And if something is in disagreement with what you write, we can discuss it on the patch.
Sure.
Good.
Maybe it can be just an inline comment as part of the proto itself, or we can have an explicit what do you suggest?
We can have it in the protos. If you're already making changes to the protos and you want to add this to the protos, sure, fine, go ahead. Oh, it's fine by me. Because in the end, that's the ultimate documentation.
Sure.
Okay, perfect. So the watchdog, this is per vendor specific. I would say we just that it's not needed to have any discussion on it. The reset to factory API. We did not include it. So it's not in the API as of right now, but it does hold the same request that Amit did before. Is anybody asking for this?
Right now, there is no requirement, but this is just one of the future items. Maybe we can park it for now and wait.
Is anyone from DT on the call to answer for requirements
Amit.
or TT?
So as far as I know, no, there is no requirement like that. And the other thing is, this is a pretty I think it's not going to be that straightforward, right? Because the factory settings, so generally the operator would do some changes on top of the factory settings before he plugs the device into the pod or into the whatever network, right? If we put it back into the factory settings, then maybe the device will not even be able to connect to the network. So in case of DT, they have some specific VLAN settings, in-band management, and things like that. Right. So if that gets wiped out, the device will not even be able to connect to the network anymore. So I think we really need to see what are the use cases and how we would need to do, if at all that requirement arises.
Yeah, so just to comment on that, and then we can end it up. It could actually be an operator-defined initial configuration. I'm fine with that. But again, it's not required by anybody, so save for later.
But we have that already, right? I mean, we have the update of the startup configuration, which is the operator defined.
Yes, but we
initial
don't.
configuration.
Yes, but we don't have the reset to that.
It's the same. I mean, for our device, if you execute the command again, then you will it will fall back to this startup configuration. Everything else will get erased from the device.
That's one way of doing it, sure.
Mhm.
Okay. Good. Okay. The last topic of the many ones we want to clear up is the distinction of the OLT reboot versus loss of communication. So this is something really specific to there's some logic that needs to be put in here, and I'm wondering if NEM needs to care about this.
But with the introduction of the reboot event, this gets cleared up, right?
Sorry, what?
If we talked about the reboot event, right, earlier.
Yep.
So if we implement that, then there won't be this confusion, right? Because in case of a reboot, you'll get a reboot event.
If the NEM gets a reboot event, or if it's, I mean, I think that was part of the problem was from NEM's perspective, and this is back to the hash news. From NEM's perspective, there's no difference between a reboot and a loss of signal. Once the signal's reacquired, NEM then interrogates the device to figure out what happened, or try to heuristically find out what happened. So it would check, is there a last reboot time type of thing? It's got to do the same operation regardless of what happened. It's got to resynchronize.
I mean, we have that time in the model, so you can query the last reboot time, and you can decide if it was a reboot or just a loss of communication.
Yeah, I think that should suffice.
I mean, isn't it what we need? I mean, when you do the initial start the initial communication with the device, you check the last reboot time, and if you lose the connection, you can check it again, and then it shows you if there was a reboot or it was loss of communication.
and this is something, back to the reboot event. It's almost like the northbound system might want to be able to query that event, right? So it's not necessarily just get it asynchronously, but when a signal is required, the controller wants to be able to say, hey, okay, let me look at the last reboot time. Okay, this thing I think rebooted. Now let me go get the reason it rebooted. And that would be the reboot event type, or the enum we talked about earlier.
But I mean, we're more talking about a device manager, which is situated on the box here, right? Because there you have a real communication to the device. And I mean, if you have a device manager which runs outside of the box, then you don't have that problem. But when you're connected to a device and the device reboots, and you lose the communication and you will not get the event. So you have to query afterwards when you have restored the communication to the device. So I don't think that the event is of any help here. Or when is that event sent?
So I think we need a last reboot reason, perhaps, and that's where that enum might come into help. But sending it as an event, I agree. I'm not convinced right now how helpful that is.
Okay, so can we just close this for now? Or do you guys think there is need for this?
This is what again?
Oh, a specific event, specific loss of connection event.
Yeah, I don't see a need. I mean, again, from a northbound system, it's going to see a disconnect and a reconnect, whether it's reboot or loss of signal. And it's got to do the same operation. Again, going back to the event about the reboot reason, that probably needs to be able to be queried as part of the last reboot time. Sending it as an event, as was just pointed out, was probably not going to be helpful.
Yep.
So if you have a device manager implementation, it might check for the heartbeat towards the device. It can detect that the device is no longer reachable on the network, and same information can be passed on to them. So if there is any network outage with that device, maybe operator can take specific action to send a field engineer and rectify the issue. But this can otherwise be known by maybe firing a API from northbound, and if you get unreachable also, that can be, but that is depending on when exactly you make the next API call. But if you have this background health check, and immediately you can detect that the device is down. I mean, this is more about loss of communication with the device. Is my understanding correct?
Yeah. But I still don't see the need for this. Because if you have a device manager, you're going to handle it internally with a retry, with something, and worst case, you're just going to throw a device dead, like this is not connected anymore event. And the loss of communication is totally hidden to NEM. And in the case NEM talks directly to the device, it's going to query the last reboot time, and that's it, period. That's what it's going to use. So I don't think we need this at all. Okay. Good. So now, going back to our discussion from last time about the events and how do we handle them on reboot. Holger, you had a message on the Slack channel. Do you want to summarize that one here as well?
Oh, well, I think I just wanted to say that we need to be able to query the current state of alarms. So, I mean, we were discussing about sending, after reboot, sending all open alarms again, but I still think that this is not possible because the device does not know if there's a I mean, there could be no gRPC connection after reboot, and when do you want to send it? And it might be, what about having several NEMs on top of the device, or I don't know. So I think the easiest way is to just query the open alarms, and NEM then has to update its internal alarm database or event database.
And that
Yeah, I thought we
means,
discussed this last week and kind of came to that conclusion too.
yeah,
I think
yes and no, because that means that we have to rework, or at least we have to change our previous decision, which is that the device does not persist alarms. That was a decision
It's
some
not
time
so much
back.
persisting, it's, well, the device has to be able to tell what its alarm state is. Whether that's persisted or a live query at the device. Somewhere on that device is an alarm state.
Right. I also wrote that there's no reason to persist it. So I think there's no reason to persist it, and you only have to be able to, when queried, respond with the current active alarms. So if, I don't know, you had a temperature alarm before reboot and you don't have it after reboot, then there's simply no temperature alarm anymore. And if the temperature is still high, then there will be another temperature alarm after reboot.
That's fine by me. So what we're saying is that we don't care how the device does it, but the device needs to be able at any given time to reply to the request of active alarms. How it's done, we don't care. It has to do either live query or persisted them. These are the active alarms I have. And
Yep,
so
and the only
yeah, go ahead, David.
The only caveat there is you're going to want some sort of timing or sequence number, so that because the client is going to be getting both the stream of alarms, events as things change, as well as querying the current state. And so as he's listening to that stream, he has to understand that stream, if there's an event on that stream, come in sequence before or after the response from the query, right? Because these things are happening concurrently. Otherwise, you could get a confused alarm. Because I query the state that it's set, but I get a clear event right after that, even though the clear event actually, you know what I mean? It's just, you got to watch out for the get and stream scenario.
Indeed. What you're suggesting is an ID number of the alarm.
Or a sequence number or something, so you can tell, again, when an alarm comes in versus when the state was queried, so that you can tell the order.
So
don't we have a timestamp or something in the alarm?
We do.
Yeah, so sorry to interrupt. So can I?
Timestamps are problematic because it depends on the granularity of the timestamp.
But the alarm that you get with the get call and the alarm that you get via stream, given that they are generated at the same time from the platform, they should have the same timestamp. Unless otherwise,
the issue is, well,
otherwise we cannot really trust anything.
So to understand this, right? So Holger, can I ask you, we already have an implementation right now, right, where the alarms are getting reported, right?
Yes,
So what is the problem with that? Why do we want to change it?
we want to change it for device managers running on a device.
Why can't they have the same behavior? Why do we want to have different behaviors for different device managers?
I think the difference is that our device manager pushes to Kafka, and you can be sure that it can always push to Kafka when it detects that there is an alarm on the device. But the device manager on the device can only send a notification if there is an gRPC connection to the device.
That's correct.
If not, you're going to lose the events.
No, but you could keep them on the device, right?
You could, yeah, but then you have to persist them, right?
Yes, but there, I don't see a reason. What is the problem in persisting them on the device? Because they need to be anyway stored in the memory in the device. The only difference is that you store it in the file system rather than in the memory.
Okay, but how can you be sure that NEM really gets the alarms? I mean, if you just send an alarm and then the gRPC connection breaks, was it sent or was it not sent?
So that is a different problem, right? That is true for any gRPC request, right? When you make a request, how are we ensuring that the other party receives it? That is we need to deal with it at that level, right? It's not specific to alarms.
Yes, but I think NEM has to deal with it. So NEM has to react when the gRPC connection breaks, and NEM cannot know if there was an alarm missing or not. And so the only way for NEM to take action is to query the device. I mean, if you do a start.
I know of no system, no device that doesn't allow its state to be queried. Right? This is standard things that devices do. Give me your state. So I don't understand the pushback here. It seems like a reasonable thing to be able to do to a device.
The pushback is because that we already have an implementation, and we're saying that okay, let's throw away that implementation and start with a new concept again.
Because fair enough, that's there are issues and situations where that implementation doesn't work, and unless every time you get unless you're going to persist these events, and every time someone connects gRPC, you're going to have to send events down the gRPC stream, whether they want them or not. It just seems like a lot of overhead versus implementing a standard device capability, which is what is your alarm state. And if you ever want to, if things are ever out of sync, give me your alarm state is always the mechanism used to resync. So I can't depend on events.
See, the problem that is cropping up, I think, is because of what we are calling as NEM, right? Because we have two architectures, where the DM is on the box, the other where the DM is outside the box, right? And it's coming up because of that, right? Because if you have the DM outside of the box, then you don't have this problem because you have access to something like a Kafka, right? And you're and as Holger is saying, that once you push it to Kafka, you don't care about it anymore.
But that's assuming that the event can get on Kafka.
Yeah.
Right.
Yeah.
I mean, network management systems, when they're out of sync with the device, it's very common to essentially query the device state. As part of that device state is the alarm state. Right. It's an operation that's been done forever. The sending events, trying to resync that way, I am not aware, not that it doesn't exist, but I'm not aware of another system that works that way. And if they're, I'm also not against doing things new and differently if they have value. I'm not seeing the value here over the more traditional give me your state.
So okay, maybe I'm losing it a little bit. So I
And
really
I don't have a dog in this fight, right? I'm not building a DMI implementation, so I'm not using it either. It's just common behaviors.
So what I have come across is purge and alarm resync. It's something that commonly operators will ask. That anyway functionality is needed, wherein you want to purge all the alarms, active alarms on a particular resource, and you want to get it fresh from device itself. So that is anyway a requirement of which we have come across. But this specific question got raised across the reboot. We earlier discussed that we don't have to persist the active alarms, and device, once it comes back after reboot, it can initialize itself and detect the alarm conditions are fresh and report them to the northbound. So we don't have to persist is what the discussion, but Holger point, the current implementation in the A4, right now they are relying on the device manager, and device manager takes care of what alarm to be sent to the NEM and what to just block it, because it is already reported to NEM.
So Andrea, what I would suggest is that at least let me check with some of the DT folks, because I don't think the change that we are talking about here is trivial on the NEM side. So we need to check with the DT folks if this can be done in the MVP timeframe. Because I could go into details of how these alarms are further processed within the NEM layers and upstream components, and then we could see how straightforward or difficult it is to take this concept change within this time frame.
Okay.
Because
Okay.
it's not a trivial change, right? It's a pretty big concept change, the way process alarms.
And just to make sure, I'm fully. I don't see a problem with the current solution with the device manager running outside. So this should be fine for A4. So it's just if you have it on the device, then we need this or might need this.
Yeah, but the other thing is that we don't want to have different behaviors from different device managers, right? Then it is going to hurt us at some point of time, right? Because then the interface is not really standardized, because the other party would have different behaviors.
Yeah, but I do not believe that we will be able to do. We'll have the same interface for both types of, because we're using Kafka or we're using gRPC. So this is different, for example. Then because one lives outside of the device, he can supervise actions like reboots and everything. So this, I mean, unless we really agree on a minimal set of things the device manager can do, always taking the device manager on the box as a blueprint, then this might be the case. But otherwise, I think it makes sense to have it in a device manager which runs outside of the box, and then it should, if it makes sense, then it should also be implemented there, if possible. Which, on the other hand, I understand means that the interface might look different for them. Yeah.
Yeah. So I am not against having an API, right, which lets us query all the active alarms, right, which are there on a device at any point of time. You could go ahead and implement it. I don't know if I'm able to put forward my thoughts. It's more about how does NEM use this API, right, and rebuild the thing. Right now, this logic stands in the DM implementation, which is sitting outside of box, right, which is calculating the delta. The question is, who calculates the delta of it?
So One thing that I missed is how does NEM work in the case of the existing Adtran device manager in reaction to alarms when at any given point in time?
So yeah, so just to like say a few words on that, right? So what happens is whenever an alarm is raised or cleared, at least the layers of NEM that I know of, it is just going and dumping it to a DB, and that's it. So you could go through the DB and see, okay, what is the current alarms that are active? Just like plus minus, right? And that's it. There really is no intelligence that is built into it right now.
So you said you dump it to a DB.
Yeah.
Whenever it receives an alarm.
Yeah, whether it is a raise or a clear, right? You just
Okay.
dump it to DB. Yeah.
Okay. And in case
Is there an alarm in the DB when it was cleared, or is it cleared from the DB? So is it only seeing the active alarms, or is it like
it has,
a
there will
Kafka
be two
stream?
entries. Yeah, there would be two entries.
And if you have the same alarm again, then you will have three entries?
One more entry, yes.
Oh, okay, so then it's not, okay.
So it basically has a complete alarm history.
So like Kafka, it's the same like
Yeah,
Kafka.
yeah,
You're just
yeah.
replicating Kafka again in your DB. Mm-hmm.
Yeah.
Okay.
Which might be okay, sorry, I don't want to judge, just understand it.
Okay. And upon device reboot, what does it happen?
Okay, so go ahead, Holger.
You don't know. Yeah, I mean, it's our device manager noticed that it lost the connection to the device, and then it tries to set up the connection again, which will take some time until the device is up and able to serve the netconf connection again, and then we query the current list of alarms. The device manager has a current state of alarms stored, and it compares the new the alarms which are currently on the device, and if there's a new alarm, then a new event will get generated. If there are less alarms on the device, then we have currently reported to Kafka, then we generate clear alarms, so that an M or whatever it is in a DT doesn't have to care about it.
So NEM only sees cleared alarms for the cleared alarms and nothing else.
And raised alarms, yes.
So new raised alarms and new cleared alarms.
No, not new.
Well,
NEM only sees, I mean, we only create a new alarm if this alarm was created during the time we were offline, or the device was offline from the device manager's point of view.
But you also clear the ones that were cleared during the reboot.
Yes, yes, mm-hmm. Yeah.
So to behave like this, the only way would be to persist the alarms on the device and make the same computation. Right?
Yeah, but I still think that there's a difference because the device manager only has to know if the device is there, and then it compares, and then it can push to Kafka. It can push to Kafka anytime. And we don't care if there's who's exactly consuming the data in Kafka. So we are always able to push into Kafka, but the device is not. And the device cannot know. I mean, can you have more than one connection? More users connected to the device. Should it? So I mean, the idea is that you. I mean, if you want to have the same implementation, so an M connects via gRPC, and then the device generates the alarm. I mean, the device knows when the last gRPC connection failed, and then it will generate the alarms for the time where there was no connection. But is this really this a NEM, or can there be two NEMs? How do you know? You know what I mean? Sorry, it's perhaps.
Yeah, if I understand correctly, let's say a device has only gRPC interface, no Kafka. So in that case, device will it know really that it lost the connectivity, and now we need to just buffer all the happenings, all the further events, and only when the connectivity is restored back, can again send all of them to the northbound, right? Was that your question? Yes, in a way, we come to know on the device when gRPC streaming connection is broken, and normally the implementation is there can be multiple processes threads that can write into a queue, message queue, and there will be one thread that pulls out the messages from the queue and puts it onto the gRPC strings. So if that gRPC connection is broken, maybe it will stop pulling the messages from the queue, and the messages that are in queue will persist until that queue length is met. So the
Okay, but
queue.
but you're saying that. So you're queuing, and when somebody connects again, and I mean RPC for it, stream events or something, and then you will just stream the events from the queue.
Yes, that's right.
So it can only be one user of the,
Yes.
of the DMI interface, right? You cannot have two users.
Yeah, so the fact that there is a stream, right, through which the events are going back, it can go only to one user. As in, that's what logically it would say, right?
I mean, you could have two streams. Why not? And then you have to replicate all the events to all streams.
Yeah, then you have to replicate all the events to all streams.
Okay, but then you have a reboot, and the first one connects, and the first one gets all the events which were queued, but the second one will not get them, right? Because the queue is empty when I mean, if he connects 30 seconds later, then he will miss the missed events.
Currently, we don't have any use case to have multiple streaming connections for the same purpose. So only when the first connection is broken or cleaned up, you can have the subsequent next connection. That is. Essentially, this gRPC streaming connection is between device manager to device. But if device directly talks to them, in that case, it is going to be again Kafka. Device will publish the messages on the Kafka directly.
Yeah, I'm fine with Kafka, so I don't see a problem for that. I thought that we have a problem for the other one, with the streaming.
Yes, mainly the problem is across the device reboot, should device persist the active alarms? That was the problem than the gRPC transport itself. Maybe that's a different problem. It's very valid what you said. Some message that is getting in the interface, what will happen to that? That's a separate problem we have to solve. I agree. But our concern was more about persistence of alarms across the reboot.
No, but I think I'm not sure if we are going in circles, right? Because some of these problems are more fundamental than the alarm thing, right? As in the reboot and this thing. Because if you have a gRPC connection, streaming connection with the device, right? And if you say that there can be two users, the problem that Holger you pointed out stands for every message that is sent across. It's not specific to the events. Right? It's not specific to the reboot scenario. Whenever an alarm is raised, do we send it to both the users or do you send it to only one? Right? If you have multiple users. So I think that's a more generic architectural or design question.
I mean, I would expect if you allow more than one stream, then you should send events on all streams. Otherwise, you have to reject the setup for a second stream.
Yeah, that's a good suggestion. If already there is an active streaming connection, we can deny the next request. Requirement. We can deny the second request for the same purpose. For streaming the events.
Yeah, but it's really what we want. I mean, for example, we use netconf, which is a standardized interface, and there you can subscribe for notifications, and you can have more than one client subscribing for these notifications. Which is, for example, currently used because the Water adapter and the device manager are both connecting to the same device and both are subscribing for notifications.
Yes, but there can be on a separate streaming RPCs or equivalent of that in the netcom. It can be altogether different logical connections. But also the messages that are being exchanged in that can be different, not for the same purpose.
Sorry, I didn't get this.
Like for example, as you said, Volta may have one indication channel with the device, and also DM can have one indication channel, right? And the events that are published are different. Here it is specific to device management, and there it is specific to management of, let's say, port or a flow or script.
No, they're actually the same. They're the same events. They're just the adapter and the device manager is filtering the events. So I mean, with netconf you have two options. You can say just give me everything, and then you get any notification, or you can say I just subscribe for these 2 or 3 or 4. But normally we just subscribe for everything and then filter after getting the notifications, because notifications are not that much. So you have then 2 managers, the device manager and the device manager getting both, and why not do the same for device manager? But I don't know. We can decide on this.
Yes, sure. And Andrea, I had one open like action item. How hard it is to store on the alarms and rescan. I have some collected discussion points with the internal discussion with my colleagues. Maybe
Okay.
in the next call, maybe we'll present and discuss in this forum. There are
Yes.
set of discussion points along persistence of this. It's not feasible, but yeah, we want to understand and discuss those points. Thanks.
Okay, perfect. Given that we are some time over, I think that's okay. We can schedule it for next time. Okay. Okay. Thanks, everybody. It was a good discussion. Let's resume next time from this. How hard is it to store it on the device, and then we can take it from there to make the final decision. I would like to make it fairly quickly. Okay. Thanks, everybody. Have a great day. Cheers. Bye-bye.
Thanks,
Thank you. Bye.
Thanks, everyone.
everyone.